Hello everybody, welcome to today's class. Now in this class we shall discuss one very important topic of organic chemistry, and which is haloalkanes and haloarenes. Now in this class particularly we shall discuss about the classification of these two type of compounds. Now if I say up to this, then you will not be able to classify them, even me also will not be able to classify them. The question is why? The answer is, if you are asked to classify something, to separate something from other, then you have to have some criteria on which we shall classify, on which we shall differentiate. Now for this class, the classifying criteria will be already written in this board, and they will be on the basis of number of halogen atoms. Second one will be compounds containing sp3 to X bonds and compounds containing sp2 carbon to halogen bonds. Now these will be our criteria for today to classify haloalkanes and haloarenes. Now without any delay, let's get started. First of all, on the basis of number of halogen atoms. Now it is clear from there that the number of halogen atoms are going to differ. Now let me show it by examples. First of all, let us consider this one. This is methane, CH4, written in this way. Now if this one is replaced by halogen, then it will be producing this. Again this halogen may be replaced by fluorine, chlorine, bromine, and maybe iodine also, and in all these cases they will produce different alkyl halides where only one halogen will be there, and since one halogen is there, in other word it will be mono, so it will be mono halides. So this is one type of alkyl halide. Now if one halogen may be there, why not two? Why not more? Yes, definitely two or more halogens will also be there. And if any compound contains two or more halogen atoms, then they will be in general termed as polyhalides. Now this one we shall discuss little bit in details. If any alkyl halide contains two halogen atoms like this one and this one, in general we are writing halogens. So this is one compound where two halogen atoms are there, so this may be represented as dihalides. And remember one thing, dihalide is one kind of polyhalide. This is one small case of this one. This is a large variety of things from where this is one particular thing. Now if it is so, then in any compound three halogens may also be there. Let me show one example, CH2, CH, CH2, and in each and every case we may have one halogen atom. If it is so, then it will be producing one compound containing three halogen atoms. So this type of compound will be termed as trihalides. So it may be written as trihalides. So in this way we shall have three type of alkyl halides where number of halogen atoms will be differing, producing mono, di, and tri-alkyl halides. Now all these cases the examples were taken from alkanes, or they were aliphatic compounds. If we take the similar type of examples considering aromatic compounds, then what will be the scenario? Now let me show this also. If we consider one benzene ring, and you know that in each and every carbon atom one hydrogen is there, but I am not writing hydrogen atoms here, just I am showing one hydrogen, and this hydrogen if is replaced by halogen, then this compound is aromatic one and only one halogen is present, so this is one aromatic monohalide. Is it okay? So due to this it is aromatic, due to the presence of one halogen it will be monohalide, so it will be monoarene. Similarly, if this compound contains two halogen atoms, then it will be again dihalides, and since it is from aromatic, so it will be arene. Okay, so in this way halides and the aromatic and aliphatic halides will be termed as mono, di and tri, maybe more also. Now come to the next one, that is compounds containing sp3 carbon 2 halogen bonds. Now before going to this, we have to first of all know this one, that is what does it mean, sp3 carbon atom. Just let me explain this one in short. Carbon, sp3 carbon atom. Now what does it mean? This is actually obtained from hybridization of the carbon atom, that is when the compound was forming, how the hybridization took place, what was the hybridization of carbon atom during the formation of this compound. And here this is not the right place to explain this hybridization in details, this may be done in another class, but today I shall show you only this part, that is how to find out whether a carbon atom is sp3 hybridized or not. Okay, so this one may be determined by counting the sigma bonds linked to this carbon atom. Now if we consider this compound, now all hydrogens carbon bonds are single bond in nature, and this type of bonds are sigma bonds. In this way we may write down this compound also. Now here also each and every bond is single bond in nature, so everything is sigma. If we take this one, this carbon is also sp3 carbon atom, because with this 1 2 3 4 sigma bonds are there, so altogether it will be 4 orbitals participating to produce this. One is s orbital and 3 p orbitals, so this is termed as sp3. This carbon is also sp3. So depending on this thing, that is any compound where one sp3 carbon atom is there, and if this sp3 carbon atom is linked to halogen atoms, and here it will be like this one linked to halogen atom, then this type of compounds may be further classified into 3 basic categories. Let me discuss one by one. Let us consider this carbon atom. This carbon is directly linked to one carbon atom, and if this one contains one halogen atom, then first of all consider the nature of this carbon. This carbon atom which is containing the halogen is linked to one carbon atom. If this be the case, then this carbon atom is termed as 1 degree or primary. So this is primary carbon atom, and the product as a whole, that is this product, is termed as 1 degree or primary alkyl halide. Okay, so this compound is 1 degree alkyl halide. Now in this way we may have 2 degree alkyl halide also. So what does 2 degree mean? 2 degree simply means carbon atom which is containing the halogen, if directly linked, if it is directly linked to 2 other carbon atoms. Consider the environment of this carbon atom. This carbon is directly linked to 2 other carbon atoms, and if this be the case, then this carbon atom is termed as 2 degree, and if this carbon contains one halogen, the nature of this compound will be 2 degree alkyl halide, and this is also termed as secondary alkyl halide. Okay, now let me write down the structure in details, and I am writing one complete example for you. CH3C, it may be anything. I am just writing one like this. One hydrogen will be there and one halogen. So if this be the case, this carbon is linked to this and this, so it is 2 degree. This is containing one halogen directly, so the substance is secondary alkyl halide. Now similarly, we may have 3 degree also, and this will be like this: carbon atom directly linked to 3 other carbon atoms. So this carbon is termed as 3 degree or tertiary, and if tertiary or 3 degree carbon atom contains one halogen, then this type of substance or product will be termed as tertiary or 3 degree alkyl halide. Now let me complete the structure. If we write down the simplest one, then it will be like this. So all CH3, that is 3 CH3 linked to this carbon atom and this carbon containing one halogen. So this is the simplest 3 degree or tertiary alkyl halide. Now in this, we may not have always methyl group here, as I earlier said that this is the simplest one. You may write down here any alkyl group, this one also, this one also. So in this way we can classify any compound, any alkyl halide where the sp3 carbon atom, here this one, this one, this one, here this one, sp3 carbon atom directly linked to halogen, and this particular sp3 carbon atom may be of 3 category depending on the number of carbon atoms attached to this carbon atom directly, and it will be 1, 2 or 3, and subsequent products will be 1 degree, 2 degree and 3 degree alkyl halides. Now come to the second category of this type, and this is allylic halides. Let me write down first. The nature of the compound is allylic halides. Now what does allylic mean? Allylic simply means any compound which contains this type of part. This is the complete structure of allylic group, but allylic group essentially will contain this portion. Any compound which contains this is known as allylic group, and this one if linked to halogen, then this is the one complete example of allylic halide. So any compound, I am repeating, any compound which contains this type of structure. Now what is the speciality of this one? Look at this carbon atom. This is CH2. This carbon will contain halogen later on, but if this carbon is directly linked to one carbon-carbon double bond, or this one is linked to this which is double bonded with this, then this type of environment is known as allylic, and this allylic group if contains one halogen here, then it will be termed as allylic halides. Now this allylic halide may be cyclic in nature also. Now if we write down in this way, let us consider this one cyclic structure. Here if we consider double bond here, now look at this carbon atom, also look at this carbon atom. From both sides it is possible. Look, this is the carbon-carbon double bond, and this carbon is directly linked to this. This is containing one CH2 group. How? Look at this, 2 hydrogen atoms will be there. So this is also, this portion will also form this type of compound, maybe this portion also we may produce from here also. Now just without making this complicated, we may write down again this one in this way in a simplified form, and we may replace one hydrogen from here by one halogen, and this type of compound will be known as cyclic allylic halide. Okay, so since this one is cyclic in nature, so the term cyclic will be there, and since this is allylic in nature, so it will be cyclic allylic halide. Now come to the third category of this type, and here we shall discuss this type of compounds. One benzene ring linked to one carbon atom, and this carbon will be sp3 in nature. If it is so, and if this is benzene, then this type of group is known as Benzylic group, and this will be Benzylic Halides. Now let me show specific example. So remember this thing, anything like this, and if this carbon is sp3, then this will be Benzylic Halides, and particular example will be like this. This is one of the Benzylic Halides, maybe this one also. Any alkyl group here, any alkyl group here, and if this one, this carbon is linked to any halogen atom, then this is also one example of Benzylic halide. Is it okay? So this environment makes the compound benzylic, and due to the presence of halogen, this is Benzylic halide. Similarly here, this environment makes it benzylic, and due to the presence of this halogen, it will be Benzylic halide. Now it is time to explain the third and last one for today, and this third and last one will be one compound or one type of compounds where sp2 carbon atom will be linked to any halogen atom. Before going to this, we have to just consider this one first. What does it mean, sp2 carbon atom? Again, I am not going in details in hybridization, only how to find out whether a carbon atom is sp2 or not. Now look at this, carbon carbon double bond, and one hydrogen here. In this bond is sigma. Now anywhere if double bond is there or more than single bond, that is, it may be double, maybe triple also. Now if more than one bond is there, the one bond between these two will be sigma and other bond will be pi. If triple bond were there, then the third one also might be pi. So only one sigma bond will be there between two carbon atoms or between two any other atoms. Now here carbon carbon double bond, so one is pi, another one is sigma. Here other two options are there. If it is hydrogen, then this will be sigma, this will be sigma. This is sigma, not due to the presence of hydrogen, only due to the presence of single bond. This is also single bond. Now look, in this 3 sigma bonds are formed, so total 3 orbitals have taken part in the hybridization directly. So one from S and other 2 from P, producing sp2 hybrid carbon atoms. So with this sp2 hybrid carbon atom, if one halogen is present, then the product will be of this category. Okay, now let me show one particular example. If we erase this one and write down one halogen, maybe chlorine, bromine, iodine, etc., then it will produce this type of compound. Now let me show one particular example. It will be CH2 double bond CH single bond bromine. So this is a compound which is vinyl halide. Now this type of compound, due to the presence of this, it is known as, this is vinyl group, and along with this halogen is there, so this is vinylic halide. Okay, so this again may be anything. Without hydrogen you may construct other compound of this category also, like CH3 this. So let me show this one also, CH3 CH3 double bond CH, and then anything else here. Due to the presence of this, the compound will be vinylic, and due to the presence of halogen, it will be vinylic halide. Again, like other case, we shall discuss another cyclic structure also. Now come to the cyclic one. If we consider this, now this is cyclic 6-membered ring where one double bond is there. Now one hydrogen is present here, another hydrogen is present here. Now from this sp2 carbon atom, if we replace this hydrogen by one halogen, then the product will be vinylic halide. And the last category for today will be aryl halides. So let me write down first. So what does aryl mean? Before going to this, just consider this aromatic compound here. This is aromatic compound. If this hydrogen is replaced by halogen, then what will be the product? The product will be this one. So this is one compound where benzene ring directly contains the halogen atom, and this group is known as aryl group, and with this aryl one halogen is there, so this is aryl halide. Okay, now in this you just know one thing, this group is also known as phenyl. So phenyl halide is one of the examples of, one of the so many examples of aryl halides. Okay, if you write down here something, write down here something, write down here something, then also it will remain aryl halide, but then it will not be phenyl. In case of phenyl, only each and every carbon will contain hydrogens and one will contain halogen, then only it will be phenyl halide. Is it okay? So in this way we may have different type of haloalkanes and haloarenes. So before going off, just let me discuss once again in short. We have learned today that alkyl halides and aryl halides may be classified depending on three conditions, which are number of halogen atoms present in the compounds, and depending on these the compounds may be mono, di, tri, tetra and so on halides. And the second one was compounds containing sp3 carbon atom bonded to halogen, and in this also we have seen that three type of compounds are possible, and in all these three so many examples are possible, which we have already discussed. And the last one we have just finished, and this is the compounds containing sp2 carbon atom which is directly linked to one halogen atom. So in this way a series of haloalkanes and haloarenes are possible. So if you go through these things more and more, then you will become very much familiar with all these things, and if you revise all of them, then it will not at all be complicated to you, and it will be very much helpful for your further studies, because all these compounds will be repeated, because all these are very often used as solvents, very often used as medicines, very often used as intermediate for the production of so many compounds in organic chemistry. Okay, so I hope this class is helpful to you. So if it is so, What to do? Yes, subscribe the channel. So we shall meet again in the next class. Bye bye.